All right, so today what we're going to be working on is called special products, called a difference of squares. A difference of squares. So please write these down in your journal. They're very, very, very easy. It's something you will see all the time. Now, typically when you look up a difference of squares, say on Google, put a squared minus b squared equals a special product. The product will always be a plus b and a minus b. That's typically what you would see in a math book or whatever you're dealing with as far as a standard formula, okay, or equation. A squared minus b squared equals a plus b and a minus b, all right? Well, all you got to do is look at these and you can tell that you got a what? A minus and a plus, and they're the same number. So we're going to do this the long way, and then we'll show you guys the shortcut. All right, so in the long way, let's just go and just do the area model. All right, it's always a good model to do. All right, to show you guys why things work out. So hopefully if you know the why, then you'll understand the shortcut better. All right, so we're going to put an 8 and a minus n to the power of 7 right there. And then I'm going to put an 8 and a plus n to the power of 7 right there. So if we do it the area method or the array method, this is how you could multiply them. We have what? 8 times 8, which is 64. 8 times n to the power of 7 is 8 times n to the power of 7. Negative n to the power of 7 times 8 is a negative 8 n to the power of 7. And then we have an n to the power of 7 times a negative n to the power of 7. So that's negative n to the power of 14. Now, when you do it this way, what do you guys notice about those right there? What's going to happen? Yeah, they're going to cancel out, and that's what happens. When you guys have what's called a difference of squares, that's what happens every single time. So what are the only two things that you're left with? The 64, right? And the what? Minus n to the power of 14. That's all you're left with. Now, does it say standard form? It doesn't, does it? So if it was standard form, I'd have to write it as what? Negative n to the power of 14 plus 64, but it doesn't say standard form, so I'm going to risk it. I'm going to see if it'll be acceptable, all right, for you guys. I'm taking one for the team here. 64, then what do we do? Minus n to the power of what? 14. All right, to the power of, oh, there we go. See if it accepts it. Ha! Awesome. So we don't have to put, hey, if it doesn't say standard form, you don't have to put it in standard form. So what's the shortcut on these babies? I'll show you the shortcut. All right, go and write this one down, then I'll show you the shortcut. We're not going to do the array method on this one. I just want you to just write this one down right there. Okay? That's it. That's it. Just write it down. All right, so I'm going to write it a little bit bigger in case you're having a hard time seeing it. It says 5a cubed minus 6a squared. And then it has 5a cubed plus 6a squared. Now you can only do this if you know that this term is exactly the same as this term, and this term is exactly the same as this term. Now see how there's a plus and a minus, so that's what's going to cancel those out. So this method will not work unless you got green equals green and magenta equals magenta. All right, so all you got to do is multiply the 5's together, and what do you get? 25. A cubed times a cubed is a to the power of 6. What are we going to put right here always? Put a minus. All right, because it's called a difference of squares. All right, then we got 6 times 6, which is 36. A squared times a squared is a to the power of 4, and you're done. All right, so what do? We find the product of the first terms. We find the product of the last terms. And what do we stick in the dadgum middle? A negative sign, a minus sign. Okay? Not a negative sign, but a minus sign, because it's this minus this. All right, we're not multiplying. We're just subtracting this one from this one. And that's all you got to do. 25, a to the power of what? 6, because we had to multiply. Remember, you have to add the exponents when you multiply. Then do what? Minus 36a to the power of 4. And you're done. All right, you guys ready? Let's just do this one. Just do it in our heads. Ready? What's 7 times 7? 49. M to the power of 6 times m to the power of 6. M to the power of 12, because we had to add them, right? What do we got to stick next to it? Minus. What's 6 times 6? Boom, done. Last one. 2 times 2. X to the power of 4 times x to the power of 4. X to the power of 8. What do we got to stick next to it? Minus. 3 times 3. 9. X cubed, x cubed. X to the power of what? 6. Boom. Done. Make it happen. All right, so our next special product we're going to talk about, all right, is perfect square trinomials, all right, dealing with the sum of squares. So I'm going to go ahead and write this one out the way it should be written. 4 plus 7a squared times 4 plus 7a squared. Now there is a pattern for perfect square trinomials, the sum of squares. Here we go. If I have a plus a times a, sorry, not a, sorry, a plus b times a plus b, that will always equal a squared plus 2 times a times b plus b squared. Also, if I have a minus b times a minus b, that will always be a squared minus 2ab plus b squared. I want to make sure you have those in your journal. All right, so if you can't see what this says a plus b times the sum of a plus b will always follow this pattern, a squared plus twice whatever ab is plus b squared. All right, and a minus b times a minus b will always equal a squared minus 2 times a times b plus b squared. So these are patterns that you'll see all the time. So when I see this, my mind automatically jumps to this pattern right here. Okay? So once again, we are going to do the array method because this method will work every single time. So you can always do it this way. All right, so I'm going to go ahead and do the array method because it's a tried and true method. If you like the FOIL method, you can do the FOIL method. All right, so basically it's the same thing. First, outside, inside, last. All right, I'm just going to do this method to help people with organization. So right here, we have 4 plus 7a squared. So what you have to do is you got to put a 4 and a 7a squared here, and a 4 and a 7a squared right there. Now you'll notice you do the same pattern. 4 times 4 is 16. 4 times 7 is 28. 7 times 4 is still 28. And 7 times 7 is 49. We got a to the power of 4 because a squared times a squared is a to the power of 4. Now, the pattern that I want you guys to notice, that when you guys are multiplying perfect squares together, notice this one will always be the exact same number. What was the difference before when we did it? When we did a difference of squares, what happened? One was negative, one was positive, and they would always cancel out. That's why the shortcut was a lot easier when you decided basically you just took a squared and minus the b squared. On this one, they don't cancel out. All right? But would you guys agree that if I took 28a squared and I added a 28a squared, what's that? That's a total of what? 56a squared. Which is the same as just saying what? Twice 28a squared. So if you guys are wondering where this 2 comes from, you're always going to be doubling this every single time. No, well, 28a squared plus 28a squared is just 56a squared. Understand this. Ready? Here's a student was asking, what about a squared plus a squared? Shouldn't that be something else? So a squared plus a squared is 2a squared. A squared times a squared is a to the power of 4. So here we're just adding the coefficients in front of the variable. Here is when you add the coefficients together, when you're multiplying things together. Here we're just adding them. Okay? So this is a very important rule to know. When are you adding the exponents and when are you just keeping them the same? All right, so our final answer, which it doesn't have to be in standard form, okay? Our final answer is going to be 16 plus 56 a squared plus 49 a to the power of 4. But in standard form, we'd have to lead out with what? 49a to the power of 4 plus 56 a squared plus 16. All right. Now, I don't know if it says standard form or not. I don't think it does. So I'm actually going to type it in this form, which is not standard form, and it should still, it says expand and what? Combine like terms. So what I'm going to do, this is the answer, but I'm going to go ahead and I'm going to show you guys what I do when I'm doing it in my head. Okay? So here we go. When I go do it in my head, I take this and I square it. What's 4 times 4? 16. All right, I have a student here. I'm just going to tell him, just be quiet for the rest of this time, please. Thank you. All right, now, plus, now what's 2 times 4 times 7? What's 2 times 4 times 7? Well, 2 times 4 is 8, times 7 is 56. All right? And then we have a squared. And then over here, we take this number and we square it. What's 7 times 7? That's going to be a positive. Why is it doing square roots? I'm hitting the plus. There, plus 49, and a squared times a squared is a to the power of 4. Now, this is not in standard form, but since they didn't say you had to put it in standard form, they should still accept it. All right, so guys, you can still do the array method. I'm going to do the shortcut method. So let me show you the shortcut method. Here we go. Write this down. Oh, dadgummit. Write this down, and I will show you how to do the shortcut method. Now I'll write it a little bit bigger, okay? 3z to the power of 5 plus 7z squared, and that's being squared. Just remember, it's always going to be a squared plus 2 times a times b plus b squared. You're like, well, what the heck is a and what the heck is b? That's what I'm about to highlight. This is our a value. Okay? This is our b value. So there's our b value and our a value. So all I'm going to do is I'm going to take my a value and I'm going to square it. So what's my a value? 3z to the power of 5 plus 2 times my a value, which is 3z to the power of 5, times my b value, which is 7z squared, plus my b value, which is 7z squared, and I have to square that. So our a value is right here. Here's our other a value. This is our b value, and here's our other b value being squared. So in my head, I'm thinking 3 times 3 is 9. Z to the power of 5 times z to the power of 5 is z to the power of 10. Okay? Plus 2 times 3, which is 6. 6 times 7 is 42. Z to the power of 7, because 5 plus 2 is 7, plus 49 z to the power of 4. This is what I'm going to type in. Now, this method is not for everybody. All right? Some people don't like it at all, and if you don't like it, that's okay. What are you always allowed to do? The array method. If this method is actually faster for you, then I would not do it the way I just did it. I would go back and just do this. And do 3 times 3, which is 9, z to the power of 10. Make that a 21, z to the power of 7. Make this a 21, z to the power of 7. When you add them together, do you still get to 42? Yes, you still get to 42. And then 7 times 7 is 49, z to the power of 4. So do the array method if it makes more sense to your brain than it does doing this pattern, okay? But this pattern will give us the same answer. And that's what you can do for the sum of squares and the difference of squares. All right, so I'm going to go ahead and type it in so you guys know we got it right. We had 9z to the power of 10, all right, plus, I don't know why, okay, plus 2 times 3 times 7, which is 42. Then we had to do z to the power of 5 and z squared, which gives us z to the power of 7. And then I had to put a plus sign, and 7 times 7 is 49, and that's z to the power of 4. And you're done. Okay? So I'm just going to do this one in my head, and we'll show you guys the process. I'm just going to talk you through. I do 7b to the power of 5 times 7b to the power of 5, which is going to be 49b to the power of 10. Then I'm going to do a minus sign because there's a minus there. 2 times 1 is going to be 14. So I got 2 times 1. And then I have to do b to the power of 5 and b squared, which gives me b to the power of 7. And then I got to follow it with b squared times b squared, which is plus b to the power of 4. All right? Now, I realize doing it in your head is not always beneficial, okay? But all I did on this one was I did this one. A minus b squared equals a squared minus 2 times a times b plus b squared. So I took this guy right here, and I squared him. And when I square that guy, that's what I got, 49b to the power of 5. Then I did 2 times a times b. So I did minus 2 times the a value times the b value. And then in my head, I did the b value squared at the very, very, very end. And that's how I got all of this. But let me reiterate, if what I'm just doing right now, if this is not making any sense whatsoever, what should you just go back to doing? Just go back and do the array method and get the problem right. Okay? So hope this was helpful. If it wasn't, just keep doing the array method and watch somebody else.